is question number 21. So question says, which row shows the equation for the dissociation of methanoic acid and nitric acid? Okay, before starting the question, just look at methanoic acid and nitric acid. Methanoic acid is a weak acid. And nitric acid is a strong acid. And we know that strong acid dissociate fully. They completely ionize in water. While weak acid, they partially dissociate in water. Okay. Now, keeping this information in our mind, let's write down our own equation and then we'll match our equation with the options. Okay, as I said, nitric acid is a strong acid. So, the equation for the ionization of the nitric acid would be like this. It will dissociate into hydrogen ions and nitrate ions. Okay. Now for methanoic acid, HCOOH, and as it is a weak acid which partially ionized, so we will show it with the reversible arrow. It will dissociate also in hydrogen ion and methanoate ions like this. So for methanoic acid, you can see this is not reversible. This is not reversible. So these options are incorrect. But we can consider C or D. For option C, nitric acid is being shown with reversible arrow, which is incorrect. So option D must be the correct option. Okay, next question. Which statement about the element in the periodic table is correct? Across a period, elements at the left side of the periodic table are more metallic than that at the right hand side. Exactly. This option is correct. It seems to correct because left hand side is the metals and the right hand side are the non-metals. Okay, but let's look at the other options as well. Option B, down the group, elements at the top of the group lose electron more readily than those at the bottom of the group. This statement is correct for the metals. As we move down the group in group 1, 2 or 3, so they become more reactive and they lose electron more readily, but this statement do not apply on the non-metals. So to say all the groups, I think this isn't the correct option. So we'll not consider it. Elements in the same group of the periodic table have the same number of the completed shells of the electron. No. Elements in the same group of the periodic table have same number of valence electrons. Not the completed shells of electrons. So this option is incorrect. Elements in the same period of the periodic table have the same number of the electron. No, they have same number of shell. So this option is also incorrect. So option A is correct in this case. Let's move to question number 23. So rubidium and cesium are both elements in the group 1 of the periodic table. Which prediction comparing rubidium and cesium is correct? We have to compare both of them. rubidium and cesium. Okay, so in the question we have to talk about the density and reactivity. As you can see in each case, density and reactivity. Okay, so we know that density is equal to mass over volume. It's mean higher the mass, the molar mass of the element, and higher would be the density. Okay. And what about reactivity? In group 1, we know that reactivity increases down the group. Now we have to keep these 2 points in our mind, that reactivity increases down the group and density is related to the mass. Higher the mass, higher the density. Okay, keeping this thing in mind, just look at the periodic table. So we have to talk about rubidium and cesium. You can see here is the rubidium and here is the cesium. Okay, so rubidium has lower mass. It's mean the density of the rubidium is low, while cesium has more mass, so density of cesium should be more, because density is related to the mass. Density is related to the mass. Higher the mass, higher the density. So mass of the rubidium is 37 and mass of the 85 and the mass of the cesium is 133. So cesium's mass is more, so its density would be greater than the rubidium. And reactivity also increases down the group, so the reactivity is higher in the case of cesium and reactivity is lower in the case of rubidium. So according to our discussion, cesium has the higher density and it also has the higher reactivity. Now move to our question again. So cesium has a higher density and the higher reactivity. So this option is correct according to our discussion. Cesium has higher density, rubidium has high reactivity. Obviously, this option is not correct. This is not correct. Rubidium has higher density. No, it doesn't have higher density. This is not correct. And neither it has the higher reactivity. Again, this is incorrect. Rubidium has the higher density. No, it don't has the higher density. Cesium has the higher reactivity. Yes, it is correct. Half of the statement is correct here. So option A is the correct one. Okay. Let's move to question number 24. The statement about the halogens are listed. All halogens are non-metallic diatomic molecules. Yes, this is correct. This statement is correct. Chlorine displaces both bromine and iodine from the aqueous solution of their salt. In halogens, the reactivity decreases down the group. So chlorine is above in the group, so it is more reactive than bromine and iodine. In this way, it can displace both bromine and iodine. So this statement is also correct. Now statement number 3, the halogens become more reactive on descending group 7 of the periodic table. No, not descending, ascending. Okay? So this is not correct. So B is the correct option here. Okay. Statement about neon. Neon, you know, is the noble gas. Group 8th A element. So it is unreactive. Yes, it is unreactive. This statement is correct. It has strong intermolecular forces. No, they are gases and they have weak forces of attraction between them. So this statement is not correct. It has a full outer shell electron. Yes. So option B is correct here. Now move to the next question. Question number 26. Substance X has the following properties. Melting point is 1237 degrees Celsius. Boiling point is 2595 degrees Celsius. It is malleable, good electrical and thermal conductivity at RTP. What is the structure of the substance X? Okay. As you can see, it has a higher melting and boiling point. It's mean it couldn't be D, because D is a simple molecule and simple molecule has lower melting and boiling point. So it couldn't be this. It is malleable. If it is malleable, then it's mean it couldn't be B and A, because ionic lattice are not malleable. And also they are the good conductor of heat and electricity at room temperature. So in this way it couldn't be option B as well, giant ionic compound, because giant ionic compounds are solid at room temperature and they are not conductor at room temperature. They are conductor only in the molten and the aqueous form. So the only option that we are left here is the option C, metallic lattice. Metals have the high melting and boiling point, they are malleable, and they are good electrical and thermal conductor. And you can see these are all the properties of the metals. Okay, next question. Which statement explain why object manufactured from the aluminium corrode very slowly? Okay, so let's look at the option. Aluminium is above hydrogen in the reactivity series. Yes, this option is correct, but it is nothing to do with this information. We have to talk about the corrosion and reactivity, so it doesn't make any sense here. Aluminium is below hydrogen in the reactivity series. No, this statement is incorrect. Aluminium is above. The object become coated with the protective layer of the aluminum nitride. Okay, what happens when we have aluminium? It's a reactive metal, so it makes a layer of the oxide on it. It makes a protective layer of oxide on it. Protective layer. Which prevent it from the further reaction with water or atmospheric oxygen. So the correct option is D in this case. Iron oxide is used in the blast furnace, contains impurity silicon 4 oxide, and which reaction removes the silicon oxide? So it's a kind of fact again. Let's write down the equation. CaO, which is obtained by the thermal decomposition of the calcium oxide, it reacts with silicon dioxide, the impurity, and it forms CaSiO3, the slag. This is the reaction which remove impurity during blast furnace. So option C is the correct option here. Now move to 29. Okay, the domestic water supply is treated before it is supplied to houses. Three statements are listed: sedimentation and filtration, treatment with chlorine, treatment with carbon. Okay, why we use sedimentation and filtration? We use sedimentation and filtration to remove solids. Okay, why the treatment with chlorine is done? It is used to kill microbes. Okay, and treatment with carbon, it remove bad odor, taste, and color. Okay, so let's match these things with our options. Sedimentation and filtration kills microbes. No, it removes solids. So option A is incorrect. And D says it removes unpleasant taste and odor. No, it's also incorrect. Treatment with chlorine. Now we are left between B and C. Okay, so option C says treatment with chlorine, it removes the unpleasant taste and odor. No, it kills the microbes. So this is incorrect. So B is the correct option here. Okay. Question number 30. Nitrates and ammonia salt are used as a fertilizer. Which fertilizer contains the greatest mass of nitrogen in 50 kg of the compound? Okay, so we have to find out the percentage of the nitrogen in each case. So let's calculate. In the first one, nitrogen is 1. So 14 multiplied by 1 divided by the molar mass of NH4Cl, and that is 52.5 multiplied by 100. So the option is 26.6%. Okay, now calculate for B. There are 2 nitrogen here, so we will multiply 14 with 2 divided by the molar mass, that is 80 multiplied by 100. Solve it, and answer is 35. Okay, so C, there are again 2 nitrogen here, so we will multiply by 2 with 14 divided by 130 multiply with 100, and the option is 21.5. Next we have 1 nitrogen here, so 1 multiply by 14, and molar mass is 101 multiply by 100, so the option is 13.86. So these are the percentage by mass values of nitrogen that we got, and you can see that B has the maximum percentage by mass of nitrogen, so this would be our correct option, because the compound which contain more percentage by mass of the nitrogen, it will give the greatest mass of nitrogen in 50 kg of the compound. So option B is the correct one. Which strategy removes methane emission? Okay, methane is basically obtained from the livestock farming. It's mean if we will reduce the livestock farming, obviously the methane emission would be reduced. So option C is the correct one. Now move to 32. Compound P is an alcohol with a molecular formula C4H10O. How many structural isomers are there for compound P? Okay, let's make the structural isomers. So it is C4H10. So the first isomer would be CH3, CH2, 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 OH. So this is the first one which we will obtain. Okay, now I will change the position of the carbon. So CH3, CH, CH3, CH2, OH. So this is the second option. Now again changing the position of the carbon and also the alcoholic group. So third isomer is this. Okay, now if I keep the chain of the carbon same, but change the position of the hydroxyl group, so a fourth option could be like this. Now if I change the position of the hydroxyl group here, then the same thing will be obtained. So these are the maximum numbers of the isomer which can be obtained: 1, 2, 3, and 4. It's mean option C is the correct one. Okay, question number 33. Alkene undergoes a substitution reaction with chlorine. Alkanes undergo a substitution reaction. Which row shows two correct statements about the reaction between the alkanes and the chlorine? Okay, so this is the free radical substitution and it needs ultraviolet light. It needs UV light. So this option is incorrect. This option is incorrect. Now the competition is between option C and D. Let me write down the equation. Okay, so what happens? Let's take a simple alkane, methane. Okay, so what happens? One hydrogen is being replaced by one chlorine. Resultantly, we get this structure here. This reaction is called substitution, in which one hydrogen has been substituted by one chlorine. So it says a carbon atom is replaced. No, this is incorrect. A hydrogen atom is replaced by a chlorine atom. Yes, this is the correct statement. So option D is correct here. Okay, so question number 34. A molecules of the compound C4H6. So C4H6 is alkane. This molecule undergoes two separate addition reactions. It undergoes addition reaction with excess of bromine and addition reaction with steam. Okay, so all the alkenes when they react with steam, they produces alcohols. All right. So if we keep this thing in our mind, then option B and D is incorrect because I just said it produces alcohol. So these might be the correct options, A or C. Now look at the first blank. One molecule of C4H10 react with one molecule of bromine or two molecule of bromine. Okay, so let me write this thing again. This is so you can see here are two double bond here. So when I will add bromine here, then what would be the situation? Let's make it. There are four carbon. So I'm writing four carbon here and completing their hydrogen like this. So one bromine would be here, one would be here, and this way. So as you can see that two molecules of the bromine are being added here. They are two molecules of bromine. So option C is the correct option. Now 35, which statement about the members of the homologous series of alcohol is correct? Okay. An alcohol with two carbon atoms in each molecule is called methanol. No. If there are two carbons, so it would be ethanol. So this statement is incorrect. Butanol can be combusted to give carbon dioxide and water only. This statement seems to be correct because organic compound on complete combustion produces carbon dioxide and water only. So we can write down the equation as well. C4H10O plus 6O2, it will produces 4 carbon dioxide plus 5H2O. This is the sporting equation. Okay, ethanol is the only alcohol that can be oxidized to carboxylic acid. Again, this is the wrong statement. Any alcohol can be oxidized to form the carboxylic acid. Propanol can be made by the catalyzed addition of the steam to ethene. If we will add steam to ethene, then we will obtain ethanol. So this option is also incorrect. Option B is the correct one. Okay, so question number 36. The diagram shows the structure of the compound called ethanoic anhydride. 1 mole of the ethanoic anhydride react with water to form the 2 moles of the carboxylic acid only. Okay, so we have to do the hydrolysis of this ester. You can see there are 2 esters group. This is the one ester group and this is an other ester group. So we have to break the bond from here. Okay, so if I will break the bond from here, so I have to add water in it. So let's see what would be the situation. I'm writing half of the molecule H C H H C double bond O, and if I add water here, so OH will be added here from the water. Okay, so what is the rest of the molecule? I'm talking about this part. So now I will write this part. And H from the water will be added here. So as you can see, both of them are the carboxylic acid. So according to the question, we have got 2 moles of the carboxylic acid only. And you can see that I used 1 water molecule here. So let's look at our options. Number of the water molecule. So number of the water molecule I used is only 1. That's why option C is incorrect and also option D is incorrect. Now the competition is between option A and B because both of them are using 1 moles of the water. Okay, now I have to make the ester by using these carboxylic acid. Okay, so let's make the ester. The carboxylic acid I used is H C H H C double bond O OH, and I have to react it with ethanol. So for ethanol I have this structure. And what will happen? OH from here, H from here will be removed and the resulting structure would be HC H H C double bond O O C H H H H and H. Now this is our final structure. If we look at this structure, then just compare it with our options. We have this part and also this part. Now this exactly resemble with this part and this part. You can see 2 carbon are here, 2 carbon are here, 2 carbon are here, and 2 carbon are here. This couldn't be the option because it has only 1 carbon here. So this is incorrect option. That's why option A is the correct one. Okay, now 37. 4 samples are analyzed using paper chromatography. P, Q, and R are the pure substances. M is a mixture of the different substances. Okay, so if you look at the spots, then you will come to know that there is one spot of Q that is exactly at the same place as M, and there is one spot of the P that is exactly at the same position as M. So we can say that P and Q, they are line up horizontally with M, so they both contain both P and Q. Why? Because they have the exact spot horizontally with each other. But you can see there is one more spot of the M. It's mean there is an other substance as well. And R, it don't have any spot horizontally matches with M, so R is not our option. Now look at the option. P, Q, and R, obviously not. P and R, obviously not. And as there is another spot as well, so we are not going to use P and Q only. We will use P, Q, and other substance. I hope it makes sense to you. Okay, now question number 38. A student is making a sample of the aqueous copper sulfate. Copper sulfate is soluble salt, and copper oxide, it is an insoluble salt. Okay, so when we have to separate a soluble substance from an insoluble substance, then the process that we use is filtration. And filtration, we just need filter funnel and paper. So all other options don't make any sense. Now move to question number 39. How can a pure sample of the barium sulfate, it is an insoluble salt. Obtained from barium carbonate. If it is an insoluble salt, it means it will not dissolve in water. So option C and D doesn't make any sense. They are not our options. We have to compete between A and B. Okay, so let's write down the equations. First, barium carbonate is reacting with HCl. So I will write barium carbonate with HCl, and it will produce BaCl2 plus H2O plus CO2. And when this BaCl2 is further reacted with H2SO4 according to equation, it will produces BaSO4 plus 2HCl. So as BaSO4 is the insoluble salt, That's why it will not be crystallized. We will dilute it with HCl, then with the sulfuric acid, filter, and then wash. So B is the correct option. Now move to the last question. A sample of the white powder X. If it is a white powder, it's not a transition element. Okay. Dissolve in water. So if it is dissolved in water, then it couldn't be D, because D is calcium sulfate and calcium sulfate is insoluble in water. Okay, so uh, when we add aqueous sodium hydroxide and a drop of a drop at a time until in excess, so in excess it is soluble. It is saying it's soluble in excess, giving a colorless solution. So if it is giving a colorless solution and it is soluble in excess, its mean option C is incorrect. Why? Because calcium is insoluble in excess and it don't form the colorless solution. So now the competition is between A and B only. Okay, next it says when we add dilute nitric acid and barium nitrate in it, then what will be formed? Obviously, it will form barium sulfate, and barium sulfate again is insoluble. It don't form the colorless solution. So B is again the wrong option. That's why A is our correct option. Thank you so much. Allah Hafiz.